Okay, so now before we do an example, one of the things that you want to keep in mind is that the ratio test is very useful when it comes to expressions that involve either factorials or exponentials or even both. Because when you take the ratio of those two, then things start to cancel out and simplify very nicely, okay? The drawback is, of course, just like with any test, it could lead to, and again, you could get the limit equal to 1, which would be inconclusive. So it could lead to not giving you any information about the convergence of the series. Okay, but again, if you see something with factorials or exponentials, that would be something you might want to use the ratio test for. So let's look at this example here. Oops. Okay, so we're going to look for using the ratio test, and we're going to use this here. Okay, so now, if we look at this, this would be definitely a good candidate for using the ratio test. So let's set this up. And so what we're going to do is we're going to take the limit as n approaches infinity. We're going to take the absolute value of the ratio of these two. Okay? Or excuse me, not the absolute value, just the limit of the ratio. Okay, so now, what are we going to do? We're going to do 2 to the n plus 1 over n plus 1 factorial, all over 2 to the n over n factorial. And so now what I'm going to do is I'm going to simplify the fraction, and I'm going to write this as the limit as n approaches infinity. Now I'm going to flip the denominator. I'm going to write this as a product. So this is going to be 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Okay, so now notice that 2 to the n, these factors here are going to cancel with all these factors except 1. So I'm going to get 2 on top. So all of these are going to cancel with all of that. So I'll be left with a 2 on top. Now, this is n plus 1 factorial. So again, n plus 1 factorial is equal to n plus 1 times n factorial, right? So that I can split that up. This is n plus 1 times n factorial. And so now this is going to cancel with this, and I get n plus 1 on the bottom. All right. Now, so that means I'm going to get the limit as n approaches infinity of 2 over n plus 1. And so where's the limit going? It's going to 0. Okay. So since rho is less than 1, the series converges. So therefore, since rho, right? So let's put this in here. So rho, come on. So rho is equal to that. Since rho is less than 1, the series converges. And that's it. See you next time.